Earth's surface is 70% water. It makes up 60% of our human body and is a vital life source on Earth. Although it is very, very important for life on Earth, don't you wonder how it even came here in the first place? 4.6 billion years ago, our planet was covered with molten rock and lava, making it impossible for water to arrive. To find the answer to our question, we must dive back 14 billion years to the Big Bang. 14.6 billion years ago, just a few minutes after the Big Bang, particles began to bump into each other. These formed the first atomic nuclei. Most of them formed to make hydrogen, which has 1 proton. Some of them formed to make helium, which has 2 protons. And very few of them, accounting for the amount at the time, made lithium, which has 3 protons.
Oxygen came around about 1 billion years later. This is when the stars started to form. In the dense hot cores of the stars, older elements like hydrogen and helium fused to form other elements like oxygen. 4 helium would make 1 oxygen. A couple billion years after that, all of the elements were swirling around with grains of silicon and carbon. Gas that somehow came together in this dust bowl ignited to form stars, one of them becoming our very own sun. Being a young, unstable star, the sun unleashed a fierce solar wind, and remaining gas was pushed away. The forces left only solid particles that clumped together into rocks, planetesimals, and the inner planets. Water could not have been one of the particles that stuck around as ice. The inner solar system was far too hot at the time. Ice would have just melted into water vapor. Water vapor would have been blown away by solar winds. Breathing and combustion used approximately the same amount of water as photosynthesis makes. But even if photosynthesis can create more water than what combustion and breathing uses, there's not enough of it to supply our ginormous oceans. This means that water could have come on meteorites, comets, or other bodies in space. These objects could have come from the outer solar system where it was cool enough for ice to form. Comets had fit all the requirements until we discovered that water there was far too rich in heavy hydrogen. Heavy hydrogen is an isotope of hydrogen that has an extra neutron. That means it has 1 proton and 1 neutron. Heavy hydrogen's proper name is deuterium. In Earth's water, for every 1 million hydrogen atoms, there's around 150 deuterium atoms. On comets, it's twice that amount. That's when we figured out that the most likely candidate for our ocean's waters is a type of meteorite called carbonaceous chondrite. Chondrite is a name for the class of stony meteorites that most commonly hit Earth. Only these types of meteorites contain water and, of course, a lot of carbon, as in the name. They formed outside the melt zone, and their water contains levels of deuterium similar to those on Earth. This suggests that these water suppliers make the oceans, clouds, ice caps, and rivers. The water that make our oceans came out of the blue. Thank you for watching my video. Please check out the other parts of my culmination project. Once again, thank you.